Hello, Year 10, and here we are again. We are going to be starting a new topic today, and it's a new topic for a new year. The name of this topic is Scale Diagrams and Bearings, although I'm going to start with the work on bearings to begin with. So bearings is all to do with angles, so over the next couple of lessons we'll be introducing the concept of a bearing and also be seeing how this fits in with some of the angle rules that we already know from perhaps year 7, 8 and 9. So our aim for today is to read and measure bearings from a diagram, but I'm going to introduce the concept of a bearing first using a compass. So you might be familiar with an 8-point compass or a 4-point compass. It is important that you know the different directions on a compass. So we've got north, east, south and west going clockwise round. They're called the cardinals, and in between those we've got the intercardinals, which are northeast, southeast, southwest, northwest. And I'm sure you've probably all heard different rhymes for remembering the order of the compass. Like never eat shredded wheat or naughty elephant squirt water. Okay, now the reason why we need to define a bearing is because just those directions alone, north, northeast, east, they aren't accurate enough. So for example, if you're walking in a direction a little bit between north and northeast, yes, there is a 16-point compass, so you can have a direction by like north, northeast. However, that being said, it's still not accurate enough. So we've already got our angles, our angle system, where there's 360 degrees in a full turn, and a bearing is just a extension of that. So for example, we define north to be 0 degrees, but we don't write 0. We always write this with 3 digits. So north, 0, 0, 0. If we went all the way around to south, well, if you think about your protractor, that would be 180 degrees. East would be 0, 90. And why don't you have a go at filling in the rest? So you could pause the video here. I'm going to pop them all in now. So northeast is 0, 4, 5. Southeast, adding another 45 is 135 degrees. Southwest is 225. Then we've got 270. And then we've got 315. Okay, now I always think it's really useful to know these rough directions on a compass, because if you see a line that's going up kind of in a northwest direction, although the diagram might not be drawn accurately, you're going to be still expecting a number around about the 315 margin. So what are these bullet points for? Well, there's 3 things that you need to remember about bearings. It is always a 3-digit number. It is always measured clockwise from north. Okay, and that is going to become super important as we progress through this topic. So clockwise from north. And the final bullet point is just to remind you that north is defined to be 0, or in this case, 0, 0, 0. North is 0, 0, 0. Okay, so I might refer back to these compass directions as we work through some questions in a moment, but we're going to now start looking at how this might appear on a diagram. So for example, here is a diagram. I have 3 towns that are labelled A, B and C, and we are going to try and work out some bearings between them. Well, how would we go about doing this? Well, first of all, we need to add some extra lines. So all I've done here is I've joined some lines from A to B and from B to C and from A to C. And I've drawn in some north lines, and unless you are told otherwise, but it's normally marked on the diagram, north is defined to be straight up. Okay, so straight up the page. So try and draw that. If you've managed to print out my sheet, your north line should be parallel to the edges of your page. Now, what we're going to do is we're going to try and work out some bearings between some different towns. The first bearing that we're going to try and work out is the bearing of B from A. And there's two different terminologies that you might hear. You might hear B from A, or you might hear A to B. And B from A and A to B are describing the same thing. You are taking a trip from A and you are going to B. So B from A means you are starting at A, and A to B means you're starting at A. So it's like we are walking along this road here. Now again, from my compass, I already know that that is somewhere between northeast and east. So I'm going to be expecting a number around about 50 degrees, but we shall see in a minute. So which angle is it that I am actually measuring? Well, I need to measure the angle clockwise from north. So it is this angle here that I am going to measure using my protractor. So I'm going to put my protractor on and let's see what we have. So notice how I've put my protractor on. I've not put it horizontally, I've put it vertically. And the reason I've done that is so I can align 0 degrees with north. So I am measuring around this angle here, because we said it was this angle that I wanted. And if we read that off, it looks to be about 66 degrees. Okay? So I can write, and you can write this underneath, B from A. Remember, we're not going to write 66 because it has to be a 3-digit number. 066. Okay? You could also write A to B is 066. For my next bearing, I'm going to try and work out the bearing of C from B. So which angle do you think this is on the diagram? I'm trying to do C from B. One of the issues that a lot of students have is they don't end up measuring the right angle. So where is C from B? Well, I'm starting my journey at B, which is here, and I'm walking towards C. So that is the direction that I'm walking in, and you can see we're a little bit further around from south. The angle that I need is the angle all the way round from north clockwise till I hit the line that I'm walking along. So it's that angle there, and it's going to be a little bit bigger than 180. Of course, that's going to now present us with another problem. If we're going to measure this angle, well, how are we going to do that? Now, you might have a very clever 360-degree angle measurer, but the vast majority of you will have a 180-degree protractor. So there's a couple of different ways that we could do this. I'm going to put my protractor the other side of the north line, because I already know that all of this to that point there is 180, and I want the angle all the way round to there. So there's two ways, like I say. You could measure this angle here and subtract it from 360, but what I'm going to do is I'm going to measure this extra bit and add it on to 180 degrees. Now that extra bit looks to be about 15 degrees. Now there's always a margin of error for measuring these things in an exam, and usually about 2 degrees out, so be as accurate as you can. So I need to add that on to 180, so I can say the bearing of C from B is 195. So that was 180 plus 15. So we've reached the point where I'd like you to try some questions, Year 10. You can access these questions if you go back to my instructions. I'd really like you to include some diagrams with these questions. So you've got a couple of options. If you've got access to a printer, print out the sheets by all means, cut them out and do the questions there. Or you will have to draw these questions out. I realise that number 2 might be a little bit of a problem if you don't have access to a printer, so just do your best, please. Just remember one thing when you're answering question 1, the angle that you need is measured clockwise from the north. So when you're working out the direction of golf balls B, F and C, you might need to do a subtraction.